So the question is, we actually let me try to rephrase it, make sure that I properly understand the question. We have shapes, and shape is just promising something. It really doesn't do anything, it's just promising us something, right? That's why it says abstract in so many different places around this code. In main, however, I guess the question is, when we say, hey, drawing, give me an area, how can we know and make sure that every time the call is dispatched to the right object? It's like, yeah. How much confidence can we have in this?
I mean, I don't want to be calculating the area of a rectangle with a formula for the act.
Exactly. It's like, okay, it seems like something works, but does it really work as to whenever there's a circle that the call is dispatched to the circle version of get area, whereas the rectangle, do we know that there is a call dispatched to the rectangle to do the computation? Well, what we can do here is that we can set a couple of breakpoints and make sure that we do go into these methods, but I'm not going to do it right now. Rather, I'd like to create another small demonstration, small graphic demonstration of something. The question is, how does it work, right? How is it really implemented? So this is what happens. And I apologize if this is going to be sort of a little bit overwhelming, but I'm going to give you a true picture because you asked. So this is what happens. When objects are created, and we create quite a few of them, right? So let's see what happens here. Well, first of all, we have a drawing. The drawing looks like this. This is an array. I'll try to draw it like a long, little piece here, right? Like that. So it has all these slots for individual references to objects. And we create, and I'll just like draw some circles, right? We create some circles in memory, and we also create some rectangles, okay? So rectangles look like this. They're all occupying memory and so forth. And then, of course, this array of references, right, which are null to begin with, they're all getting populated with the actual references. So this begins to refer to the circle, this refers to another circle, maybe this one begins to refer to a rectangle. So we have a link to each one of these objects. So the array truly kind of keeps track of all objects in memory, and that's an easy part. Okay. What I'd like to make absolutely clear about this picture, this drawing, is this. I like to make it very clear that in memory, when circles and when rectangles are created, the only memory that they occupy, these objects, when we say new, and new everywhere here, the only memory that they really occupy is what's in the data part of that object. Just an observation. So therefore, what happens is the point here is that all these methods, get area, draw, get perimeter, whatever else we give to our objects, all methods, they also physically sit somewhere in memory. All executable programs belong someplace in memory. But that memory of executable code is not part of the memory of our object, because all objects share methods. It's like there is nothing unique about method that's called on this circle or on this circle. The method is exactly the same. There is no need to make code part of this, allocation of an object. The code sits absolutely on the sideline. All executable code does not take space inside of our objects. All executable code, each single method in all of our classes is placed in memory at a separate location. So that's message number one. Okay? So the objects are created, but they include physically at that address where they created in memory. They only include the data attributes, the width and the height, the radius, the database ID which we added to the top of our hierarchy. That is part of our objects. However, none of the code is part of these individual objects. All the code is put on the sideline. And the reason for that, because once compiled, code should be executable only. It should not be, mangled in any way at runtime. So it safely sits in a memory segment which is only kind of like, which can only be executed, right? So that's interesting observation. So now I would like to sort of like zoom into this area of the code, okay? So what happens is this. When you make a method, so say you have an object, right? So you have an object, shape, right? So essentially we have this reference to the shape. And it's part of our array. So we know there is an actual object referenced by this place in the array, so we have multiple elements in the array. So what happens is that this reference to the shape, when we use this reference to make a call like this, we say, okay, here's our shape, let's call get area, okay? If that's what we do, then of course what happens is that we need to find two things. We need to find that method get area, this method. We need to find it in memory, and I kind of like try to draw it with like compiled CPU commands, that make up this entire method get area. Like there's some CPU commands. So we need to find it. But more so, we know that there are at least two versions of it, right? There are two versions of it. Get area for a rectangle and get area for a circle. So the question is, which one do we call, this one or this one? How do we resolve this? How do we make this possible, right? Because at runtime, by the way, this is called dynamic polymorphism, is that dynamically at runtime, based on the information that we have here, a reference to a shape, we need to make a quick decision which one to call, which one get area to call. That is a circle version of a rectangle version. So how is this implemented is that, okay, let me try it one more time. So now I will erase this because there is no direct call like this in reality. Okay, so I will erase these lines, and instead what happens is that this call goes into a special area, is like a C++ programmers call it a virtual table call table. And what happens is that this reference here to the shape object contains a hidden data piece. So there's a second little data piece which tells us that there is an address. There are two addresses here stored. One points to get area of circle, and another one that points to the get area in memory for the rectangle. Because we know there's two get areas that exist in reality, that we coded them in two different classes. And so when this code is made, there is a hidden data piece here that says basically, which works as a switch. Use this one or use this one. So in reality, this class shape contains a hidden, something like this, private private, I know, I'll call it int. It's not int, it's really a memory address pointer. Private int offset, we'll call it like v table offset, which is a hidden data in the shape. That's how most compilers implement it. So then, when dynamically we come across this reference in memory, and we'll quickly say, oh, okay, go ahead and get area. What it does, it takes this little offset and adds it to this set of pointers in memory, and it figures out that maybe, you know, if it's 0, then let's call get area that belongs to the circle. If it's I don't know, maybe 4 or 8 or something like that, then it basically adds this number of bytes to this table and says, oh, this is the address which points me to the right. You know, maybe it's this piece. This is the one that points me to the right method. So there is, it was a very good question. Thank you, Bruce, for this question. Is that in reality, in implementation, there is something that's hidden from us, and you know, a piece which basically at runtime, it's populated at runtime, because when we say new circle, this hidden data piece for the circle is updated here inside of our array. And when we say, you know, new rectangle, there is a different little hidden area, hidden data piece stored for the rectangle. And so at runtime, the pair of these pieces, first is the reference to our object, but there's also sort of like an offset into the table of methods that are available, and this offset will be pointing indirectly, like there's one level of indirection and another level of indirection, which will be taking us eventually to the right method implementation. So by the way, if you ask me, does this setup with abstract class slows down the execution? Yes. Some small amount of CPU cycles is actually lost because it takes a little bit of extra time to find and make the method call at runtime. So thank you.